All right, so now we're going to take a look at domain and range and how those are represented in a linear function. And really, we can kind of move this on to any function. We're not going to worry about any other functions in grade 10 math, but as you move into grade 11 and 12, you're definitely going to take a look at what are some unique functions and how does the domain and range affected in those. So each linear function has a set of numbers which will satisfy the context of the scenario. Okay, and again, there's different groupings of numbers that we can take a look at, but we're going to take a look at how can we do this here. So for a generic equation, again, you've heard me say that in the past, there's no context. Each value of the independent variable, okay, or the x value, will have a set companion value of the dependent variable. Okay, so that's the y value. So every x has a y. Okay, we've looked at a few examples in the past. If we have one value of x, we're going to have a very specific and unique value of y that is common to those two. Okay. When context is applied, okay, again, word problem, context, to a problem, not every value of x and y will be possible to solve the problem. Now, I'm just going to, here's the example that we're going to use for this. Let's think about the first example that's given in the previous lesson. If you have to go back, you can take a look back at that. But the example was a class of 23 students is made up of male and female teenagers. The two variables that we used were the number of male teenagers in class and the number of female teenagers in class. Now, can you think, are there any values which will not satisfy the variables? Now, it might be tough to kind of think about this, but we're going to kind of work our way through here. Number one, okay, we cannot have any decimals. We cannot have a decimal number of people. It's just not possible. Okay, every person is a single person. It's a whole number. It's one person. Okay, if we have 6 people, it's 6. It's not 6.2 or 6.4. Okay, no decimals. We also can't have a negative number of people. Okay, and then on that same note, we can't have more than 24 or more than 23 males or more than 23 females, because then to make that whole thing work, we would have to have negatives. Okay, so there's kind of a couple different things that we can look at. So we know this, okay? Our x's and our y's now cannot be decimals and cannot be negatives. That's just something that it should be implied, but we often have to tell people exactly which numbers we're going to end up using. So when dealing with functions, the domain represents the values which will satisfy the independent variable. Okay. So the values that are going to represent the independent variable. So in the case that we had before, I believe we did x was our independent variable, and so x was the number of males, in fact, in this one here. So our domain of that, we'll have to say that we cannot use a decimal value, and nor can we use a negative value. And we're going to take a look at how we do that in just a little bit. The range represents the values which will satisfy the dependent variable. Okay, so the domain represents our x. Okay, we can think of this normally as our x value, and our range is going to represent our y, so x and y. Typically, but again, we can use any letters in that. It's just typically it's going to be x and y. There are two different ways to describe the domain and range of the function. Both can be 100% correct in the way that we use them, but sometimes there will be different kind of ways of using them as well. The first is using types of numbers. That's our first way to describe our domain and range. And we're going to take a look at 4 different types of numbers that we could, in fact, use. So for those of you that are following along in the notes, we're going to move on to the next page, or kind of slide to the next page here. The first type of numbers that we might want to use is something called natural numbers. These are what I would call our counting numbers, 1, 2, 3, 4, and on and on and on. Okay, so we're not dealing with negatives. We're not talking about 0 at all. These are just positive counting numbers. No decimals, no fractions, no negatives, and no 0. Okay, these are positive counting numbers. Now, someone's talking about wanting to be positive in class and staying positive. So if you want to stay positive, you stay natural. Yeah, those are our natural numbers. And again, sometimes we don't like decimals and fractions, so we stay positive, right? Natural. Okay, we want to stay natural. Au naturel. All right. Now, what happens if we want to include 0 as well? Then we use something called the whole number system. Okay, our whole number system means that we are dealing with 0 as well, but still just our counting numbers. So it's the natural numbers plus 0. Okay. Back in the day, they wanted to something to use to represent nothing, and so then they added 0, and then they made a new numbering system called the whole number system. Now, what happens if we want to include negatives into this whole thing? Then we're going to use our integers. Okay, integers are positive and negative whole numbers, right? -2, -1, 0, 1, 2. So these are, like I said, positive and negative counting numbers, still no fractions, no decimals. Now, finally, right at the end here, we are going to use something called the real number system. That also implies that there's a fake number system. Well, we actually call it the imaginary number system. We're not going to worry about that. Do not worry. That is university level math. We're not going to worry about the imaginary numbers. We're just going to take a look at the real number system, and this is all possible numbers that we could use. Okay, so this is all possible numbers, including non-repeating decimals, fractions, and irrational numbers, which are non-repeating. So we have a couple different things. We could say rational and irrational as well. That's in a part of that. But again, if we're dealing with the rational numbers, we're also dealing with irrational numbers when it comes to domain and range. So we're just going to simplify it and just say the real number system, which is a big R. And it is, so that's that. Okay, that is done. Now, if X is a part of any one of these systems, we're going to use something, this little a part of symbol. So let's say that X is a part of our natural number system, only counting numbers. We're going to say that X is a part of, this little kind of E symbol here, the natural number system. We're going to use N for natural numbers. Okay? Or if, let's say, we're using Y, let's say Y is a part of the whole number system, we're going to say Y is a part of the whole number system. And you can do the little stylized W if you want, or you can just do W. That is just fine. Or Y is a part of the real number system. That means that Y could be any number. This means that Y can just be 0, 1, 2, 3, our counting numbers. This tells us that it's not going to be 0, but it could be anything else. So if we take a look at the previous example, okay, that we went through, previous example, it was male and female students. It means that X has to be a part of, it could technically be 0. It didn't say that there had to be at least one or not, but we're not going to have negatives. We're not going to have any real numbers. So we're going to say that X is a part of the whole number system and Y is also a part of the whole number system. That would be our answer from the previous system. Okay. Again, it just tells us that we can't have negatives, we can't have decimals, and that would give us enough information to go forward in that. We could also, the second way that we could also do it is we can use inequalities to represent. Okay. So let's say that we have a lower end but no upper end. So let's say that there's kind of a start but no end. So let's use an example of distance traveled. Okay, so how far have I ran in my lifetime? Well, I can't ever have run a negative amount of distance, but I could keep on going forever and ever. So we're going to say that x has to be greater than or equal to 0. Or maybe we're not going to include 0 at all, and we're going to say that y has to be less than 24. Okay, so maybe 24 is our maximum that we have, and so then y would have to be less than that. It could go into the negatives, right? So that would mean that it just has to be less than that value. Or let's say that, sorry, that was a mistake there. If it has a lower end, it's going to be, I'm going to use, apologize for that, still greater than. Let's say it has to be greater than 24. Okay, it starts at 24 and goes up, or goes up from 24. Let's say that it has an upper limit but no lower limit, then x would be less than and equal to 0, or y would be less than or less than 10, let's say. Okay, so that's if we have an upper limit but no lower limit. Again, that means that it's going to keep on going to infinity, but we don't necessarily write in the infinity part. And let's say that a line has an upper and a lower limit, so we're going with a specific range. So let's look at the previous example again. We could have from 0 to 23 students, or 23 males, and from 0 to 23 females. We could write that as 0 is less than or equal to x, which is less than or equal to 23. Okay, so that would represent from 0 to 23. But let's say that we don't want to include 0 and 23, we just want to include the numbers inside. We could say that 0 is less than y is less than 23, and that means that we're not including those outside bracket limits, but it would be everything on the inside. So let's look at a couple of examples to go through. We're just going to look at graphs. We're not going to worry too much about the context right now. If you have questions on context, ask me about that later. Maybe I'll make another video on that later, but for now we're just going to look at the some graphs here. So this graph right here, you notice that we go from 0 all the way up to here, okay? And so we have our x and we have our y. Our x's can go from 0 up to, it looks like 6, okay? So from 0 to 6. So we would say that 0 is less than or equal to x, which is less than or equal to 6. It means that our x value can be between 0 and 6, and this is our domain. Our range is also from 0 to 6. It happens to be the same. So our range can be from 0 is less than or equal to y, which is less than or equal to 6. So our domain and our range are both between 0 and 6. Notice all those values work because it's a straight line. Okay, all those values are going to work for that. The second one here, I'm going to assume that it keeps on going forever. I forgot to put my arrows in when I made this, but it keeps on going forever and ever. It means that it's going to, all the x values here, okay, here's our x's, here's our y's. All these x's are going to be used, and it's going to keep on going forever and ever on to infinity. So there's a couple different ways that we can write this. We could say that x is a part of the real number system. Okay, that would be one way to write it. And we could also say it goes from negative infinity is less than or equal to x to positive infinity. I think that is a little easier, just means everything is included. Range is the same thing. The y values, it's going to keep on going up and up and up. It's going to go down and down and down. So y is also a part of the real number system, or we can say from negative infinity all the way to positive infinity. And that's the little infinity symbol. Okay, last one. Now, this is one that there could be a couple different ways of looking at it. And I'm going to do kind of both here, our domain and range. So in this case here, it almost looks like we just have positive integers, right? 5, 4, 3, 2, 1, and 0. So it looks like for x, it's going to be 0, 1, 2, 3, 4, 5. Sorry, the other way around. So what I'm going to say is that x has to be a part of I'm going to say that it's the whole number system, because it doesn't look like it's going into the negatives. And then I would also say that y is also a part of the whole number system. But let's say that maybe we're continuing on. We can't see if it stops or not. Maybe it's just integers. We could say that x is a part of the integer number system. and y is a part of the integer number system because we can't really see is it stopping or not. Okay. Again, I didn't give you kind of empty things like this. We can see that it does stop exactly there. And because we don't have a line there, it means that it's only going to be those values. It's not going to be the ones in between. Now again, if you're following along with my class here, the assignment that you're going to work on here is LI.02, numbers 5 to 8. And you can work on those. That continues on with the previous assignment. Questions 6 through 8 actually reference the previous questions. Question 2 to 4 are referenced in questions 6 to 8, but now we're dealing with our domain and range of those two.